This is LeetCode question number 701. Insert into a binary search tree. This is medium question. Let's get into it. It has a lot of sum up, 10 times bigger than sum down. Yeah, please check this question. Given a root node of binary search tree BST and a value to be inserted into the tree. Insert the value into the BST, return root node of the BST after the insertion. It is guaranteed that the new value does not exist in the original BST. Note that there may exist multiple valid ways for the insertion as long as the tree remains the BST after insertion. You can return any of them. For example, given the tree, okay, this BST is given and then we need to insert. In this case, BST left child is always smaller than root 1 and right child always bigger than root 1. So in this case, 5 is bigger than 4, so it's going to 7 here. At this time, 5 is smaller than 7, so it's going to left. So pending has left child of 7. Okay, let's implement it. I'm gonna use the recursion to BST traverse helper node, and then recursion has two parts. First is base case and second part is recursion relationship. Base case is if node is known. This means it is somewhere here or here or here or here. I will return new tree node. Has value is value. And okay, let's make a recursion relationship. If the value is smaller than the value, this means 5 is smaller than 4, it is time going to right. So node right is helper node right. Otherwise, node left is helper node left. Then return node value. Then return helper put root as segment. Okay, I think I'm done. Okay, let's test it. In this case, 3 is 4 and 5. This time 4. Node value 4 is node is none, no, so this one is skip, and then node value is 4 and value is 5, so this one is bigger, so it's going to node right. Helper node right, and then now is here. This one is still not known, so you skip, and then node value is 5 is smaller than 7, so it's going to node left. So it's going here, and now node is known, so this one is execute, and then return true node val, and then now going here. Node left, this now is here 7. The node left is this one, so 5 is here, and then return, and then return node. And then now is here, and node right of 4 is updated this one, so this one is also updated. And then finally root is root, and then return the root value. Let's check. Okay, looks good. Submit. In this time, it take worst case, tree is screwed like this. In this case, when you recursion, it take linear time with the linear space system stack. Thank you.